This is the easiest way I found to describe what a correlation function is and how it's accumulated. You actually accumulate an autocorrelation function. The horizontal line is time, and then we divide it up into equal space time, called the sampling time or bin time. And you see the small hash marks, say they're all 5 microseconds apart. And then you start to look at the fluctuating light. So in the first bin, you have 2 photopulses you register. In the second one, you have 1. In the third, you have 3. In the fourth, you have 0, then 5, and on it goes. The total duration of the experiment is the sampling time delta t times n, the number of bins you accumulate. Now, in this picture, it looks like you could do it with an offline computer. You could fill up a memory with all the little photo pulses, and you can, but it's not in real time or efficient yet. This linearly spaced correlator that I'm showing you here makes it easy to describe how you create a correlation function. The correlation function itself, C of tau, can be described either for analog correlators as an integral, or it can be described the way you see it there, the ensemble average of n, the number of photopulses at some time 0, which is when you push the start button, times the number of photopulses delayed a certain delay time tau, where tau is some multiple of that sampling time. And so you form the products, you add them up, you divide by NP of 1, 2, 3, 4. That NP is the total number of bins, and that defines your correlation coefficient. So if you look at that first line, the correlation coefficient at tau 1, the first delay time, is 2 times 1, 1 times 3. So I'm multiplying each bin times the next bin. You add that up a million times and divide by the number of bins, and you get your first correlation coefficient. But now you want to look at counts that are 2 bin times away. So if you look at the second line, you see that you multiply 2, which is the first. In the first bin, there are 2 photopulses, right? But now you multiply it by 3, which is in the second. See the 3? Can you move the arrow over to 3? And then you multiply 1 times 0, and you keep going down the list. Okay. If you do this for a number of bin times, 1 delta t, 2 delta t, 3 delta t, up to m delta t, m will give you the number of channels in your correlator. And so this is how you accumulate an autocorrelation function. It's not a hard concept statistically. It's the ensemble average of the number of photopulses at some initial time times the number at some delay time as a function of that delay time. This is a linearly spaced correlator, has its limitations for broad distributions, and it's not in real time. You could gather up these photopulses in a computer RAM, and then offline, while you're missing the action because it's still scattering light, that's why it's not real time and it's not 100% efficient, you start multiplying it up and accumulating the function. Then you go back in and grab a bunch more new data. Anyway, this is...
Do you get more data with a smaller time interval, like nano?
No. Those time intervals depend on the ultimate...
I'm just thinking how many...
correlation. If you have very small particles, then the correlation function will end very quickly, and you better choose that sampling time smaller, like 1 microsecond. If you have very large particles, they diffuse more slowly, and the correlation function is going to go out for a very much longer time, and so you pick that sampling time to be much bigger, 10, 20, 50 microseconds. At some point in the mid 80s, we were able to automate all that. Before that, people who knew light scattering would typically have a rough idea of where to place the sampling times, but more importantly, they'd simply measure an initial correlation function. They'd notice whether the baseline was coming down to a flat portion. If not, they'd start over with a longer sampling time. If they noticed that they weren't catching the beginning of the correlation function very well, then they would stop, delete, start over with a shorter delay time. So you did it by understanding the procedure. But when it came to something like the BI-90 and people using it who didn't know laser light scattering, we had to automate all of